Hi, this is Babak. In this video I'm going to solve the following problem for you. Let me read the problem for you first. Evaluate the following integral. We have this definite integral that you see here. We are supposed to calculate the value of this integral. This problem is chosen from JEE Advanced Paper 2 2019. This exam is a very hard entrance exam for Indian higher education institutes for engineering and technical programs. That would be a good idea if you pause the video at this point and try to solve this problem yourself first. If you get the correct answer is I equals to 1 over 2. Okay, now let me solve the problem for you. I want to use a lemma for definite integrals that I proved in the previous video, so I will not spend time on proving that again here, but I will put the link to the previous video that if you want to go and check that video, you will see the proof of this lemma there. So if f is an integrable function on the interval from a to b, then the function f of a plus b minus x would also be integrable on the same interval. And if I calculate this integral, these two integrals would be the same. Okay? So I want to use this lemma to prove this problem again. So here, what is my integrand? My integrand is a function of theta here. It's 3 square root of cosine theta divided by square root of cosine theta plus square root of sine theta to power 5. Okay, and then here a is equal to 0 and b is equal to pi over 2. Now let me make this integrand. Okay, so f of a plus b minus, instead of x I use theta because my variable in this problem is theta. This becomes f of 0 plus pi over 2 minus theta. And this becomes f of pi over 2 minus theta. So this means that I need to replace pi over 2 minus theta instead of every theta that I see in this problem. But you know that cosine of pi over 2 minus theta is sine theta, and sine of pi over 2 minus theta is cosine theta. Okay? So this means that if I do this substitution, every cosine that I see changes to sine, and the sine will change to cosine. Okay? So this becomes equal to 3 square root of sine theta over square root of sine theta plus square root of cosine theta to power 5. Okay, so now this tells me that if this integral is equal to I, the integral of this function from 0 to pi over 2 is also I. So therefore I can write I is equal to the integral from 0 to pi over 2, 3 square root of sine theta over square root of, I can write it cosine first, it doesn't matter because I have the addition between these two, and sine theta to power 5 d theta. Okay, and then the idea is the same as the previous problem. So here I have I equal to this, I have I equal to this, so I can write I plus I is equal to, instead of the first I here, I plug this integral in, so this becomes the integral from 0 to pi over 2, and then I have 3 square root of cosine theta over square root of cosine theta plus square root of sine theta to the power of 5 d theta, plus for the second I replace the second I with this integral that I just found, yes? So this becomes integral of 3 square root of sine theta over square root of cosine theta plus square root of sine theta, and then to the power of 5 d theta. And of course you know that if I have integral of f of x in the interval from a to b plus another integral with the same interval but g of x d of x, then I can write integral from a to b and I can simply add these two integrands, yes? So I will do the same thing here. But here on the left hand side, of course, I plus I is just simply 2i, and then the right hand side becomes integral from 0 to pi over 2. And the good point here is that I want to add this integrand to that integrand. I have the same denominators, so I will keep the denominator the same. So it becomes square root of cosine theta plus sine theta, so square root of sine theta, and then I have to power 5. And then when I add this integrand to that integrand, I can factor a 3 out. Then I will have square root of cosine theta plus square root of sine theta, and then I have d theta. But then what happens? This implies that one of these factors, because you see that this is exactly the same factor, so this will be cancelled with this one, and 4 of these factors are left. And then of course this is not exactly equal to I, but it is equal to 2i, but that's a minor problem, because if I want to calculate I could just simply divide by 2. So then finally I get this idea that I is equal to 3 over 2, I pull 3 out as well, and then divide by 2, 0 to pi over 2, then I have d theta, and in the denominator I will have square root of cosine theta plus square root of sine theta, and then I have to power 4. So what I need to calculate is now, let me call this integral itself j, and then when I calculated j, to calculate I need to multiply it by 3 over 2. So I focus my attention on calculating j. Okay, how should I calculate j? So I would write j is equal to, what I do here to calculate j, I would write it from 0 to pi over 2, and then I will factor a square root of cosine x out. Okay, how? So I would write it in this form. I will take a square root of cosine theta out, and then from this one, 1 is left. The other one becomes a square root of tangent of theta, yes? And then of course I have a power of 4. Yes, so I kept this power of 4, and inside this pair of brackets I factored the square root of cosine x out. But then this will be raised to power 4. So 1 over square root of cosine theta to power 4 is 1 over cosine to the power of 2 theta, which is secant squared theta. So then I can write it in this form. So it becomes integral from 0 to pi over 2 secant squared theta d theta, and in the denominator I will have 1 plus square root of tangent of theta to the power of 2. Yes? Okay, now what can I do here? I want to calculate this integral. I made a mistake. This is not 2, this is 4. So let me clean that. This is not 2, this is 4. Okay. Now what I do here to solve this problem, I will take 1 plus square root of tangent theta to be equal to a new variable u. I differentiate both sides. The derivative of a square root of tangent is 2 square root of tangent multiplied by the derivative of tangent, yes, but the derivative of tangent is secant squared theta, and then I have d theta. On the right hand side I will have du. Okay, if I multiply both sides by the denominator of the left-hand side, then I will have secant squared theta d theta is equal to 2 square root of tangent of theta d theta. Yes? But of course, from here, I can see that the square root of tangent of theta is equal to u minus 1. So then this means that, oh, sorry, that is not d theta, this is du. And then this implies that secant squared theta d theta is equal to 2 times u minus 1 du. Okay? So that is good, because now I can write this in terms of my new variable u, and this is just u to power 4, yes? And what I need to do now is to see what are my new limits. Okay, so I would say that theta goes from 0 to pi over 2, so this implies that what is u? If I put theta equal to 0 here, the square root of tangent of 0 is 0, so u becomes 1. But when I put theta equal to pi over 2, in principle this is an improper integral, because tangent of pi over 2, when it becomes a positive infinity, and if I add 1 to it, it is positive infinity again. So this turns into an improper integral. So let me just write it, and then I will take this one with me to the next page. So the integral j is the integral from 1 to pi over, to infinity, to positive infinity. And then in the numerator, I can write 2 times u minus 1 du, and in the denominator, I will have u to the 4. Okay? So let me just take this with me to the next page, so that I have enough space. Okay, so I will paste it here, and then I will continue. But this is a fairly easy improper integral to calculate. Okay, so in principle I should write it as the limit of the integral from 1 to some variable, say r, to u minus 1 du over u4, and then send r to positive infinity. Yes, so let me now calculate this integral inside. So this is also simple, so this becomes the limit. I can take 2 out from my integral, and I divide the integral to, in this form, I write u over u4 minus 1 over u4, and then I have du. And then of course I will send r to positive infinity. But then this becomes the integral, the limit of 2 times the integral from 1 to r du over u3 minus the integral from 1 to r du over u4. Okay? And then r goes to infinity. Now I need to calculate these two integrals, which are very, very simple ones. So this becomes u to power minus 3. So it becomes u to power minus 2 divided by minus 2. So it becomes minus 1 over 2u squared. Okay, 1 to r. And the next one becomes it becomes positive 1 over 3u to power 3. Again, goes from 1 to r. Yes, hopefully, let me double check everything. So I brought this up u minus 3, so the integrand becomes u minus 2 over minus 2, so that is correct. And then this becomes u to power minus 4, so it becomes u minus 3 minus 3, so I brought this down, so it becomes this. And then I change this one to positive. Yes, everything seems right. And now I write this, the limit, r goes to infinity, 2, and then it becomes 1 over 2, if I replace them, minus 1 over 2r squared. The other one is plus 1 over 3r cubed minus 1 over 3. Yes? And now I am sending r to infinity, so this term will vanish, this term will vanish, then I am left with 1 over 2 minus 1 over 3 multiplied by 2. So it becomes 1 over 3. Yes, 1 over 2 minus 1 over 3 is 1 over 6. I multiplied by 2, I get 1 over 3. Yes, but this is the value for the j integral. if you remember, if we go back here, the value of the integral that I am looking for is 3 over 2 times the j integral. So this means that my I integral is 3 over 2j. It is 3 over 2 times 1 over 3, and then I will get that I is equal to 1 over 2, that is mentioned in the problem itself. Okay, I hope that you also enjoyed this problem. Until the next video, be safe and goodbye.